with our study of vectors by solving more problems using vectors. Alright, two velocity vectors v1 and v2 when added together gives a resultant v3 equal to 2 meter per second I minus 1.5 meter per second j. If v1 is 4 meter per second I minus 3 meter per second j, what is v2 in magnitude angle form? Well, you need to understand this question well in order to do this. What is given here is v3. v3 is the sum of v1 and v2. You are also given v2 and you are told to find v1. Is that right? So we know that v3 equal to v1 plus v2. We know v3, we know v1, therefore v2 will be v3 minus v1. That means you can obtain the x component of v2 by subtracting the x component of v1 from the x component of v3. In other words, the x component of v2 will be 2 meter per second I minus 4 meter per second I. This is the x component of v3. Subtract the x component of v1. That will give you the x component of v2. And the y component of v2 will be the y component of v3 minus the y component of v1. Alright, let's do that. Now v3 equal to v1 plus v2, and that v3 is 2 meter per second I minus 1.5 meter per second j. And v1 is 4 meter per second I minus 3 meter per second j. Therefore, now this is your v3, this is your v1, therefore v2 will be v3 minus v1. So we subtract the I components first and then the j components. So the x component of v3 minus the x component of v1 will give you the x component of v2. The y component of v3 minus the y component of v1 will give you the y component of v2. So that will be 2 meter per second minus 4 meter per second I. This is the x component of v2 plus negative 1.5 meter per second minus negative 3 meter per second j. This quantity minus this quantity of j. Alright, that will be 2 meter per second minus 4 meter per second is negative 2 meter per second I, and this double negative will become positive. So this will be 3 meter per second minus 1.5 meter per second, that is positive 1.5 meter per second j. So we obtained the vector v2 in terms of its x and y components. Well, now we need to obtain the magnitude and angle. If you know the x and y components, how would you obtain the magnitude of the vector? Magnitude of v2 will be square root of x squared plus y squared. Right? This is the x component, negative 2 meter per second. This is the y component, 1.5 meter per second. Therefore, the vector v2 will be this vector. The magnitude of v2 is square root of x squared plus y squared. and that will be 2.5 meter per second. This is your vector V2. So V2 equal to 2.5 meter per second is the magnitude. We now need to find the angle of vector V2. Now, you should understand that the positive x-axis is that way. So the angle is this angle. But you can now find this angle by using the opposite side and the adjacent side. Alright, if this is the angle theta, you don't need to say that this is the angle. The angle is actually this obtuse angle. And that obtuse angle is such that its opposite side is 1.5 and the adjacent side is -2. Is that right? Therefore, the direction of V2 is given by this angle theta with the x-axis. So tan theta equal to y divided by x. Y is 1.5, x is -2. So tan theta is 1.5 divided by -2. You see that negative sign is very important there. This tells me that the y value is positive, the x value is negative, therefore the angle is a second quadrant angle. That information is very important for you. Now, this tan theta is, if you put this in your calculator, can you now do that? Tan inverse of 1.5 divided by -2. What does that give you? Tan inverse of 1.5 divided by -2 will give you -37 degrees. Now, those who understand inverse functions, you know that tan inverse is defined only in the fourth quadrant and the first quadrant. So, the calculator gave you a fourth quadrant angle. Tan inverse of 1.5 over -2, the calculator gives you -37 degrees. Is that wrong? Well, actually no. It is this angle that the calculator gave you. You see, let me draw that for you. The calculator gave you this angle. There you are. This is the angle -37 degrees. Now remember, an angle measured from the x-axis in the clockwise direction is negative. Now, what we need is this angle. And if you notice, what all you need to do is to get the second quadrant angle, add 180 to -37. So -37 plus 180 will give you this angle theta. So this is the fourth quadrant angle. There you are. Now, since the x component of V2 is negative and the y component is positive, you must know that the angle theta is in the second quadrant. Oh, the angle theta is in the second quadrant, not the third quadrant. So please change this into the second quadrant. This is a second quadrant angle. Is that right? Let's draw those quadrants there. If this is the quadrant, this is the first quadrant, that's the second quadrant. So the angle theta is a second quadrant angle. And how do you obtain that second quadrant angle? Add 180 to -37. So theta equal to 180 plus -37, which is 180 minus 37. That is 143 degrees is that angle. Alright? Now, situations like this are very common in adding vectors. Now, you must know what quadrant the angle falls, and therefore what will you do to get that angle. Do not always depend on the calculator. The calculator will obey strictly the mathematical rule, because tan inverse is defined only in the first and fourth quadrant. If you are looking for a second quadrant or third quadrant angle, the calculator will not give it to you directly. You need to do this manipulation to get that angle. Okay, let's do another problem. A particle's position coordinates xy are 2 meter, 1 meter at t equal to 0 and 8 meter, 5 meter at t equal to 5 seconds. Find V average, average velocity from t equal to 0 to t equal to 5 seconds. What is the definition of average velocity? Average velocity is the rate of change of position. Now, what is significant here that you notice? The position, the x position of the object has changed. You see, originally the object is at x equal to 2. It changed to x equal to 8. So its x position has changed. Also, its y position has changed. Initial y position is 1 meter. The final y position is 5 meter. That means there is a change in the x position. There is a change in the y position. Therefore, you need to calculate the average velocity in the x direction and then calculate the average velocity in the y direction. Is that right? Because our initial definition of average velocity, this is what we did. V average is delta x divided by delta t. Now, we should now understand this as the average velocity in the x direction. So we're going to call it V average x. V average x is delta x, the change in the x position divided by the change in time. And V average y will be delta y divided by delta t. You can do this problem right away here. You can see, tell me what is my delta x? What is the change in position in the x direction? It is 8 meter minus 2 meter. So that will be 8 meter minus 2 meter divided by 5, and that will be 6/5 meter per second I, because it is in the x direction. That is the change, that is the average velocity in the x direction. Average velocity in the y direction will be delta y divided by delta t. What is delta y? The change in the y position. It will be 5 meter minus 1 meter. That will be 5 meter minus 1 meter over 5. And that will be 4/5 meter per second J. So, you have an average velocity in the x direction, which is 6/5 meter per second I, and average velocity in the y direction, which is delta y over delta t. That is 4/5 meter per second J. And so, what is the average velocity? How do you write the total average velocity? I can write it as V average equal to 6/5 meter per second I plus 4/5 meter per second J. That is the average velocity of this particle during that time interval of 5 seconds. Alright, I don't know why I wrote this on.